Homework 3.5, Rational Functions, Video 11, homework due Wednesday, May 27, 2020 at 11:59 p.m. This final video, as the three preceding it, correspond to questions 17 through 21 in the homework. All right, let's do one more putting it all together, graphing a rational function. There's one thing I have yet to illustrate, and that's a hole in the graph. Spoiler alert, there's a hole in this graph. So let's attack it. Symmetry. If we put in a negative x into the function, we'll get a negative x minus 2 on the top, but the x squared on the bottom will kill the negative. Now, this is clearly not the original function. It's only off by that single negative sign. So it's not equal to the original. So we can dismiss that right away. But is it the opposite of the original? Well, stick a negative in front of the original and see if you can make a match. Negative in front of the original. Now I have to do something with this negative. The denominator is currently matched, so let's not put it down there. Let's put it to the top, which would distribute and make a negative x plus 2 over x squared minus 4, which doesn't match this. So this is not equal to f of negative x. This is not odd. This is not even. There are no symmetries. Well, I take that back. There's not y-axis symmetry or origin symmetry. This will have a rotational symmetry, as I'll point out at the end. Actually, it won't even have that because of the hole, so forget I just said that. All right, y-intercept. Hey, finally, different intercepts. For the y-intercept, we have to put in 0. Okay. 0 on the top gives 0 minus 2, which is negative 2. 0 on the bottom gives 0 squared minus 4, which is negative 4. Negative 2 divided by negative 4 is 1/2, or 0.5 when we go to graph it. Okay. X intercept. Now here's where we got to be careful. In the past, I've said that you can solve this by solving the top equal to 0. Because if you multiply both sides by x squared minus 4, that would disappear, that would stay 0, and we would get x equals 2. But do you see a problem with saying x equals 2 is the x-intercept? What happens when you plug 2 into this? It makes the top 0, and makes the bottom 0. Now let's pretend we didn't notice that yet. Let's go to the vertical asymptotes. For the vertical asymptotes, you solve the bottom equal to 0. So we solve x squared minus 4 equal to 0, and let's assume that we can do that already. That's a double line arrow since I used a single line for approaches earlier. Let's assume that we've done that already and we got x equals 2 and x equals negative 2. Remember, to find vertical asymptotes, you have to make the bottom equal to 0 but not the top. Did we not just get finished saying that this makes the top equal to 0? Another way to think about a vertical asymptote versus a hole is when a value tries to simultaneously be an intercept and an asymptote. That's when we have to scrutinize it a little bit more closely. Now, we can check the degrees and everything by factoring the denominator into x minus 2 and x plus 2. And we can see that both of the x minus 2's have the same degree. So if you really want to scrutinize it, yes, it will be a hole in the graph because the degree in the denominator is not greater than the degree in the numerator. So here's where we have to be careful. There is a vertical asymptote at x equals negative 2. It makes the bottom equal to 0, but not the top. However, there's a hole at x equals 2, which means this is not an x-intercept, so there is no x-intercepts. Very sneaky, very dirty, but this is why I wanted to do multiple examples to show you these issues. You can't be a hole and an intercept at the same time. A hole occurs when an intercept, when a value tries to simultaneously be an intercept and an asymptote at the same time. Horizontal asymptotes. Compare degrees. Greater degree is in the denominator. That means that the horizontal asymptote is y equals 0. Let's graph what we have. Now I'm going to postpone graphing the hole for a moment because I don't know quite where it is yet. But I'll show you in a moment how you can actually locate exactly where it is. Okay, so we know that there's a y-intercept at 1/2, so let's go up 1 and put a dot halfway in between. We thought there was an x-intercept at x equals 2, and if we put that, then we would run into trouble when we tried to draw the vertical asymptote there. Now that's not where the hole would be. I'll show you how to figure out where the hole would be in a second. We do have a vertical asymptote at -2, so we can go back here and drop that. And we have a horizontal asymptote at y equals 0, also known as the x-axis. Now I don't have a lot of evidence, so I'm going to need to get some more points. And again, in the homework, they'll tell you what numbers to use. And I can't capitalize on any symmetries. Let's pick a couple of points to the left of -2, because that's where the vertical asymptote is. So let's just put in -3 and let's do -5. I can do -4, but we'll do -5. I know what happens at x equals 0, there's a y-intercept. So let's pick a number between -2 and 0, like -1. And let's pick a couple of numbers to the right of 0, like 1 and 2. Again, in the homework, you'll be given these values. You wouldn't have to come up with them on your own. All right, let's figure these out. If I put -3 on top, I get -3 minus -2, which is -5, divided by. If I put -3 on the bottom, I'll get 9 minus 4, which is 5. Oh, -5 divided by 5, that's -1. That's convenient. If I put -5 in, on the top I get -5 minus 2 is -7. On the bottom I get -5 squared, which is 25, minus 4, which is 21. That reduces to -1/3. I know where that is, it's about -0.3. Let's put in -1. On the top I would get -1 minus 2, which is -3. On the bottom, I would get -1 squared, which is 1, minus 4 is also -3. Okay, -3 divided by -3 is 1. That's convenient. Let's put in 1. 1 on top is 1 minus 2 is -1. 1 on the bottom is still -3, so we get 1/3. This is looking a lot like an odd function where we're getting opposite outputs. More on that in a moment. Let's put in 2. We get 0 on top and what am I doing putting in 2? I already said there was a hole in the graph. I have no idea where that is yet. By the way, in calculus, 0 over 0 is called indeterminate. You learn what to do with that later, but not now. Well, I want more evidence over here, so let's put in 3. 3 on top gives me 3 minus 2, which is 1. 3 on the bottom gives me 3 squared, which is 9, minus 4, which is 5, so 1/5, that's about 0.2. All right, let's plot what we know, and then I'll show you how to find where the hole is. When we go back 3, we go down 1. So go back 3, go down 1. When we go back 5, we go down 1/3. So down a little bit. I think I have enough evidence to do this. Remember, you got to connect the dots and work around the asymptotes. When we put in -1, we get +1, so we got a dot right here. When we put in 3, we get 0.2, so over 3 just barely goes up some. So connect the dots and work around the asymptotes. Now we know there's a hole at x equals 2, so we could just erase above 2 and put a hole, but there's actually a way to locate where it is. The trick to locating where the hole is to cancel these factors, and that will leave 1 over x plus 2. I can put 2 into that. If I put 2 into that, I get 1/4. This is called the reduced version of f of x. In fact, these are the same graphs with the exception of this has a hole in it and this doesn't. And I'll show you that on Desmos here in just a second. So this point would actually be at 2, 1/4 because 1/4 is the value I get when I put 2 into the reduced function. Let's Desmos it. Hope I'm not making you dizzy. Okay. So we had x minus 2. By the way, you have a problem like this on the homework. Every example that I've done in the past 4 videos have been problems that I pulled from the homework. I modified this one a little bit. It was x squared minus 49 on the bottom and x minus 7, but I didn't want it to be so far to the right. Okay, so let's turn off the asymptote. Actually, let's put it where it belongs, which is at 0. So move on over to 0, please. Thank you. And we had one vertical asymptote at -2. So let's put this over at -2. A little bit more, there we go. So looking good. And because it's the last one, let me make it look the way I want, which is dotted red lines for the asymptotes. Being real persnickety here, but it's been a long day. In case you're wondering, the time is currently 5:36 p.m. But might as well do it really nice. Okay, so there's that. Now, if I were to drag this over, if I were to get in the graph and drag over to 2, it's going to show that there's a hole in the graph. You see it right there? But clearly that point is somewhere. If I were to graph another function, we'll say g of x, since I've already defined f of x, as this function after it got reduced. In other words, after I factored and canceled and left 1 over x plus 2. 1 over x plus 2. It's the exact same graph as the other one. See, there's the 1 over x plus 2 graph. And let me turn it off and turn on the other one. And there's the other graph. So see, they're the same graph, almost. Let me turn off the black one. Because the difference between the two, when I cancel the factor that made both sides equal to 0, is I actually have a point at 2 now. It's at 2, 1/4, right there. And that's where the hole in the black graph is, at 2, 1/4. I'm showing you way more than you're going to be responsible for on the homework. On the homework, it will not ask you where are the coordinates of the hole. But there is a way to find them. You just have to reduce the function and then evaluate it at the place where the hole is. Come on, get back over there. Right there. All right, so that's the end of these. So if you have any questions, let me know. And just a reminder that 3.5 is the last homework assignment that's on test 3, which will be available on Monday, December 25th at noon, and will be due at midnight, or 11:59 p.m. on Wednesday, the 27th of May. Did I say June? I think I said June. Test 3 will be available at noon, that's what I said, on Monday the 25th, and it will be due at 11:59 p.m. on Wednesday the 27th. You know how to get a hold of me if you have any questions, so you guys have a good day.